When students solve simple multiplication story problems before learning about multiplication symbolism, they will most likely begin to writing repeated addition equations to represent what they did. The quotient 24 divided by 6 is represented in three different ways. 24 division symbol 6, or 6 division symbol 24, and 24 fraction bar 6. Remainders can be dealt with two ways. It can be either remain a quantity left over or be partitioned into fractions including decimals. A remainder can be discarded, leaving a smaller whole number. The remainder can force the answer to the next highest whole number. The answer is rounded to the nearest whole number for an approximate result. Students will be able to use the same models, sets, bar graphs, and number lines for any questions. Request. Start by having students think about contexts that involve arrays such as paradigm formations, such as seeds in a classroom, patches on a quilt. Then assign a number that has several factors, for example, 12, 18, 24, 30, and 36. Have students build as many rectangular arrays as they can. Then have them record their answers by drawing them on grid paper. For each, write the corresponding multiplication questions. For students with physical disabilities who may have limited motor skills to manipulate materials, try the factorized applet. Not obvious that 3 times 8 is the same as 8 times 3, or that in general the order of the numbers makes no difference, the commutative property. The array is a quite powerful illustration of the commutative property, as shown on the examples on the PowerPoint. Students should build or draw arrays and use them to demonstrate why each array represents two equivalent multiplication expressions. The associative property of multiplication is a fundamental and flexible solving problems. This property allows that when you multiply three numbers in an expression, you can multiply either the first pair of numbers and then multiply the answer by the third number, or multiply the last pair of numbers and then multiply that answer by the first number. 5 hops of 0 will put you on a number line at 0. 1 hop of 5 will put you at 5. The distributive property of multiplication over addition refers to the powerful idea that you can split, decompose either of the two factors in multiplication problems into two or more parts and then multiply each part by the other factor and add the results. Division by 0. Can you show me how many are in each group? Can you show me how to share 5 oranges with 0 children? You can't. Students who struggle with solving word problems need to spend adequate time thinking about the problem and imagining the situation. Students should spend time talking about and later thinking about what the answer might look like. What is happening in this problem? Some trucks are bringing dirt to fill up holes. What will the answer tell us? It will give us how many tons of dirt we need to fill the hole. What will that be, the small number of tons or the large number of tons? About how many tons do we estimate it will take? If there are 1,000 trucks, it will be 7,300 tons. That models are rarely used with word problems, such as the dirt problem, is that the large numbers are very challenging to model. General problem-solving strategy of try a simpler problem can almost always be applied to the problems with unwieldy numbers. A simpler problem strategy has the following steps. Substitute small whole numbers, model the problem, write an equation, write the corresponding equation, calculate, write the answer in complete sentences. Keyword strategies suggest that if you see the words all together or in all in a story problem, that means you should add, and left or fewer indicate you should subtract. The word each, they would say suggests multiplication. For 5 plus 4 equals blank plus 3, some students might say it's 9. However, they would be wrong. They could use a number balance to illustrate the relationship meaning of the equal sign. Solving 24 minus 7, students may subtract 4 minus 7 as 7 minus 4 for an answer of 23. Instead, have students model the problem with single digit numbers and show how you cannot subtract 7 cubes from 4 cubes. 6 plus 0 equals 7, or 12 minus 0 equals 11. Use story problems that introduce adding and subtracting 0 in a meaningful context that students can act out. Students don't use addition to solve subtraction situations. Students don't use multiplication to solve division. Avoid the root use of fact families to teach the inverse relationship as the emphasizing procedure without having students see the inverse relationship. Students believe that they should always get a larger answer in an addition problem or multiplication problem. When students point out these patterns, say that these ideas are only true for some numbers. Students guess, just add, or use the operation you've been studying all week to answer the word problem. Focus on the structure of the problem using graphic organizers or the story problem sorting activities discussed in the chapter. Students forget about the remainder and do not include it in the answer. Give students problems from anonymous students that have the remainder interpreted improperly. Have students grade the problems and share the findings in the class.